Hello dear students, I am Pratima. I welcome you all to this video. So today we are starting exercise 3, class 10, linear equations in two variables. Now why should we learn it? We learn to solve many real life problems using the concepts which when two unknown quantities we have to find. Sometimes it happens there are two unknown quantities but relations are given, we have to find the values. There we use this concept of linear equations in two variables. We frame the equations from given information, then we solve the equations to find the variables using different methods, maybe algebraic method and graphical method. Algebraic method is again can be many types. Maybe we can use substitution, we can use elimination, we can use cross multiplication method. Now what is a equation of two variable? An equation which can be put in form of ax plus by plus c 0, where a, b, c are real numbers, but the condition is a and b are not both 0. It is called linear equation in two variable and x and y. For example, 3 times of x plus 4 times of y plus 5 is equal to 0. Maybe your only 3y is equal to plus 2 is 0. This is where the coefficient of x is 0. But both will not be 0. Now, examples of pair of linear equations in two variables. That means if there will be two equations with the same format, that means some x, some y, some constant, we say this is the pair of linear equation having same variable and they are two variables. So the general form of linear equations in two variables are a1x plus b1y plus c1 is 0, a2x plus b2y plus c2 is 0, where a1, b1, c1, a2, b2, c2 are all real numbers and a1 square plus b1 square is not equal to 0 and a2 square and b2 square is also not equal to 0. For this condition, sometimes it has no meaning because sum of squares can never be 0. Now, these two linear equations are in the same way two variables x and y. They are called pair of linear equations in two variables. So when we draw the graph of two equations on the same plane, we get three situations. One is the two lines will intersect at a point. The point of intersection is the solution. The two lines will not intersect. These lines may be parallel or these two lines may be coincident. Graph of one line lie on the other. So let us again summarize what the concept are used to learn the exercise 3. Two linear equations in same two variables are said to be pair of linear equation in two variables. The pair of linear equations is consistent if it has a solution, either a unique solution or infinite many solution. I know these two terms are confusing, but while solving some questions, we will come to know. A pair of linear equation is inconsistent. So one is consistent, that means there is solution, we can find x and y, and sometimes it is inconsistent when it has no solution. Now, let us write the detail. The pair of linear equation two variable a1x plus b1y plus c1 is 0 and a2x plus b2y plus c2 is equal to 0 if the condition is a1 by a2 is not equal to b1 by b2, then the pair of linear equation is inconsistent. The graph will be pair of intersecting at a unique point which is solution of the pair of equation. If a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then the pair of linear equation is inconsistent. The pair will be pair of parallel lines and pair of equation will have no solution. So either on the graph they will be intersecting, the point of intersection is the solution, or they may be parallel. And it is called inconsistent. There is no solution. Have no solution. Here it has solution. This point is solution, the intersection point. Or third one is when a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the pair of linear equation is dependent and consistent. The graph of the coincident lines, that means the graph you will draw, one goes over other. This is the condition if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So now we are learning three equations, three relations. A1 by a2 is not equal to b1 by b2, then it is a unique solution or consistent. If a1 by a2 is equal to b1 by b2 is not equal to c1 by c2, then it is inconsistent or no solution. We get parallel lines. And all the three ratios are equal to each other, then it is consistent. But there will be many solutions. Each point of this line will be solution when one line goes over other. The pair of linear equation may be solved algebraically by any of the following methods. These are the algebraic methods: substitution, elimination, and cross multiplication. It may be also solved geometrically or graphically. So we'll learn one by one. First, we are writing how to write an equation in exercise 3.1 and how we can draw the graph. So let us revise again because graph is very important. When we draw a graph of two equations in the same plane, the two lines will intersect around a point. The point of intersection is the solution. They may be not intersecting, they are parallel. So there will be no solution. And third is two lines will be coincident, graph of one line on the graph of other. I am coming to exercise 3.1, question number 1. Aptak tells his daughter, 7 years ago, I was 7 times as old as you were then. Also 3 years from now, I shall be 3 times as old as you will be. Isn't interesting? Represent the situation algebraically. Frame the equation. So here there are two unknown quantity. One is Aptak and other is his daughter. So what we'll do, we'll take one value as x, one unknown value as y. So I'll write let Aptak's present age be x years and daughter's present age be y years. So now, according to the question, 7 years ago, that means before 7 years. 7 years ago, Aptak was 7 times the age of the daughter. So at 7 years ago, Aptak's age was how much it will be? 7 less. So x minus 7 years. And 7 years ago, his daughter's age was y minus 7. She will be 7 years less. Now, according to the question, Aptab was, the Aptab is 7x minus 7 was is equal to 7 times age of the daughter at that time. So y minus 7. At that time it was y minus 7. So x minus 7 was is equal to 7 times age of daughter. Or simplifying, x minus 7 is equal to 7y minus 49, or x minus 7y is equal to, I'll shift your 7 to this side, it will be minus 42. This is equation 1. Now coming to second information. 3 years from now, that means after 3 years. After 3 years, Apta will be 3 times as old as his daughter at the time. So after 3 years, Apta age will be 3 years more, so x plus 3, and daughter will be y plus 3. According to the question, x plus 3 is equal to 3 times y plus 3, or x plus 3 is equal to 3y plus 9, or x minus 3y, I'm taking xy both this side, this will be 6. So this is equation 2. So we can also write this equation as x minus 7y plus 42 is equal to 0, and x minus 3y minus 6 is equal to 0. So we represent the situation algebraically. Now we will represent graphically. So I've taken a graph paper. First I'll draw the graph of this equation. So here x is equal to minus 42 plus 7y, or I'll write 7y minus 42. Next I'll give a value to y. For example, y I am taking as 6. Then x will be 7. In place of y, I will put 6. In class 9, you have learned how to draw the graph. So 42 minus 42, that will be 0. So I got one pair of value, y is equal to 6, x is equal to 0. Second, y is equal to 7. Then x is equal to 7 into 7 minus 42. 49 minus 42 is equal to 7. Another pair. Now third one, y is equal to 8. So x is equal to 7 into 8 minus 42. 56 minus 42, it will be 14. So I got the table in this way, x and y. The value of x is first 0, y is 6, x is 7, y is 7, x is 14, y is 8. Now coming to second equation, or I can plot the graph now. So I'll take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so on. Here 1, 2, 3, 4, 0, 6. 0, 6 will be here. 2, 2, 4, 2, 6, 0, 6. 0 6 7 7 7 1 2 3 4 5 6 7 7 7. Next is 14 8 14 12 13 14 14 8 1 2 3 4 5 6 7 8. So this is 14 8. This is 6. So you will draw a line joining these 3 points with help of scale. So you have to write the equation here. X minus 7y is equal to minus 42. Next I'll go for second one. X is equal to, I'm taking another color so it will be distinguishing, 6 plus 3y. Next I'm taking y is equal to 0. X is equal to 6 plus 3 into 0. That will be 6. Y is equal to 2. X is equal to 6 plus 3 into 2. That will be 12. 6 plus 6. That will be 12. Third one is I am taking x is equal to 4. X is equal to 6 plus 12. That will be 18. So I am getting the table x and y. X is your 6, y is 0. X 12, y 2. X 14, 8, 14. Sorry, 18. This is 4. The point is 6, 0. 6, 0 is this point. 12, 2. 12, 2 is this point. 12, 2. Then is 18, 4. 1, 2, 3, 4. So you have to join these 3 points. I hope you have understood. Now you can draw yourself. Take a graph paper. So this is the graph. The line is your x minus 3y is equal to 6. Next is question number 2. The coach of a cricket team buys 3 bats and 6 balls for rupees 3900. Let us say buys another bat and 3 more balls of the same kind of 1300. Represent this situation algebraically. So there are 2 unknown quantities here. One is cost of bat and cost of ball. Cost of one bat, let cost of one bat be rupees x and cost of one ball be rupees y. Now you make the equation. Cost of one bat is 3x. So cost of 3 bats will be 3x. One ball is y, 6 ball will be 6y. So 3x plus 6y is equal to 3900. Equation 1. See, second information is he buy another bat. That means 1x, 3 balls, 3y. This gives 1300. This is equation 2. So this is the representation algebraically. Now coming to graphically. So graphically